All right, guys, this is one of my favorite, or I'm most excited probably about this presentation. Don't mean to shortchange anybody else, but I'd like to introduce Mark and Dylan with Yeti Welding. They are a couple of our end users. They utilize Trimble scanning and Trimble Fill Link out in the field, and they have allowed us to be able to take a little peek at some of their workflows. What they're going to be focusing on specifically is how to utilize point clouds in SketchUp and in their design process. So thank you once again, guys, for being here. Really do appreciate it, and we'll go ahead and turn the time over to you.
All right. Yeah, cool. Thanks, guys. So about 2 years ago, we encountered LiDAR scanning. As a background, Yeti Welding is a full-blown metal fabrication shop and operation where we do design build projects, and we need to solve the question of how do we go from in-field measurements to translating that into CAD programming. And our solution previously was take a laptop out to the job site and measure it with a tape measure and build realities and into the Trimble scanning solutions. And we now own a Trimble X7 LiDAR scanner, and that has been our go-to for almost 2 years to do any of our in-field site measurements and verifications so that we can build the products that we need. And looking at the history, we almost have not used a tape measure to build any of the projects that we have in the shop or outgoing of the shop over the last 2 years. We've been successful at just using the LiDAR scan to get the data that we need to build. And we've been pretty confident in building a workflow. And the workflow that we built on this, surprising to a lot of people, but not to us, is we have been using SketchUp. And I'm going to have Mark share his screen, and he's going to show you some of the a few scans that we've done with the LiDAR and how we were able to utilize the scans in making renderings of what we've got.
Yeah, so we'll do a few stations around an area, and you can see SketchUp does more of a perspective view, so it's a lot easier to see what you're doing other than like Rivet or something like that, where everything is viewed like this in more of like a plan setting. So that's where we like SketchUp, is you can really get in there and see a corner without everything getting in your way. So on a project like this, we'll scan a ton. You probably don't need to scan that much, but the goal is to get this main beam going around the whole deck, and then the existing posts that we have to attach to. And so this one was perfect because we've got all these weird angles and stuff like that. And you can kind of just draw your rail and dictate exactly where each post is going to land and make sure your corners are super tight. But that's kind of what we use it for. We can get this whole place. If there was rail down here, we could have got that as well, all in the same scan. Later on, we did do this bridge, but I had to wait for the wood to get out, so couldn't show that in one whole scan. But so that's kind of how the feel for railing, if you're going to do something like that,
works.
Yeah.
And so our workflow right now for you Trimble users is we go with the LiDAR out, we take our stations, and of course out in the field we're using Field Link to make, and register all of our data in field. We use it right on the tablet, the T10, and we use Field Link to get it all put together. And then right in the field, we're able to cut and clip the section boxes of exportable data that we would like to use. And for the most part, surprisingly, we've been able to make a section box, make our point cloud significantly smaller, use our phones and hotspot the tablet, and send that E57. Usually we compress it into a zip file, a zipped compressed file, and I'll send it into the office. Mark will pull it up here in SketchUp, and then he has the data that he needs. So we're taking a whole lot of the he said, she said this is how it is out of the in between the field and the office for that data. And we're just doing it all off of FieldLink. So some might ask the question of, are you using anything processing after you get scans, such as RealWorks, a product that Trimble offers? And the answer is no. We just go straight into SketchUp because SketchUp itself is really user-friendly when it comes to point clouds. And we feel that SketchUp and what Trimble is doing to elevate point clouds each and every day and SketchUp is making tremendous changes each and every day to make it easier and more user-friendly. And so Mark's been able to use some section boxes, which I'll have him show that even once the scan data is inside the computer, how he is able to change and view different options.
Yeah, so section box is a little finicky inside SketchUp, but it is easy once you get used to it. You kind of have to figure out which views you need to go in. But it works the same as FieldLink once you're in this top-down view, and you can draw a box, and it will just clip out that section of the scan. And it just makes it super useful. I can come in here, I can do this, I can make 5 different boxes, and SketchUp will allow you to go into each clipping box that you create and turn it on and off whenever you want to. And then you can use your same section planes and stuff, and it will also cut the scan just how it cuts the models. And I think that works in every software that I've seen, but it is super user friendly, and I don't know, it's probably the easiest software that I've used when it comes to drawing on top of a point cloud instead of getting a model made from somebody else.
Yeah. Some end users will actually take the model and then send it off to somebody to build a solid within the points and then export to detailers. We're finding ourselves time again teaching people how to do the workflow that we have particularly set up. And a lot of people will ask, well, don't you just use the point cloud to build a solid model off? And the answer is no. We're able to actually see a lot more of data clear enough, as long as you have a fairly decent, good PC to process the data, to where we just build and render right on top. How has this helped us, particularly in our own business? One, it's given us those real-time views that once we build the model, we can show the client exactly what it's going to look like with a 3D model rendered inside versus just sending a rendered model and having to use their own imagination to fit the pieces into the space. And this gives us options, and it really helps out when we start to find visions in projects where the architect called out a specific detail, or the engineer called out a specific detail, and from one page to the next on construction plan, surprise, they didn't fit. This is able to really show that to our contractors or engineers or architects that, hey, here's a problem. For instance, on this staircase down towards the lower bottom of this staircase, we needed to have a structural member to hold this staircase up particularly, but as you can see, there's a pipe in the way. And it's not common to anybody who's using these kind of products to know that when you're doing survey that we're discovering problems. And this is one of those examples where it's like, hey, we have to make some different things because of this. The plumbing was on a different page than the architectural stairs that were there. And so from plumbing to architectural stairs, you can see the problems that we had there. It's helped us in our business go from probably 40% rework, where we would derive rework being our project did not fit or projects were out of dimension, mainly driving back to the fact that we took infield measurements and they were incorrect, going from infield measurements to design, to now we're probably about 90 to 95% accurate when it comes to our modeling and detailing, because we're actually able to get real in time, real live views of what's happening. And so now the 5% of rework, the 5 to 10% of rework that we're doing mainly comes off of a fabrication error and not necessarily back to does it fit. And it's helped our business out tremendous because we're able to show and paint those pictures of, hey, it didn't fit because of this reason. The anchor bolts were in fact in the wrong spot. Maybe the layout guys actually put them in the right spot. When the concrete guys poured, it shifted those embed bolts, or the embeds themselves. Maybe the mud just shifted them. Maybe it was everybody did it right, but this kind of with the point clouds, it shows us this real difference. For another example, we have here a larger project where we are going to be involved in multiple different areas. And this is a multi-layered scan that we didn't take all at one time. It was actually in a couple of different phases as they finished retaining wall and did a couple of other things where we're able to offer difference. And I'll let Mark speak to you about how he was able to verify that the footings were off in this one.
Yeah, so this one, I think I edited this one already, so I couldn't show you what the original pergola looked like based off print and then their footings. But this was about as close as I could get to their footings, and this was super nice to show. Their footings were a little below and a little dirt was on top, so it wasn't a perfect scan, but I already knew it was off, so I didn't need to make sure I could see the exact top of it. I just needed to see their locations. So this was pretty easy. I shrunk it just a little bit, and then I started taking screenshots and sending them off and being like, hey, this is going to be either on the edge or hanging off the footing you put in there. And then same with that one and over here. And then I was able to pull a dimension between these two and show them that it wasn't going to be even because everything was supposed to be centered on the pool and the hot tub. So this is where it became super useful, because instead of reworking how we're going to build the whole thing and then being mad wrong just because we did it off their footings, I'm able to show them before we even step foot with any steel on the project, and I can show them that, hey, this is wrong. Now it's in their ballpark to correct it and make it right, or tell me to just build it wrong, basically. And yeah, so this project was for sure one of those where that needed to be done, and
the scanning helped out.
Yeah, it helped out a ton, and we were able to see everything we needed to. And then we had just random rails and stuff around here, so I just had extra time and went around and scanned those as we were moving on with the project. And once it came around to the point where they wanted those put in, I had all the data already, so nobody had to go back to site. So that's another really nice thing about it, is as the customer adds things or you have things later on, you can get information before you're ready to even act on it. And that's been super helpful.
Yeah, it's been super helpful. Go ahead and zoom in on our ADA ramp over there, ramp railing. This would probably be a lot of really applicable to a lot of the individuals that we have here on the Zoom call, is these ramps. As a fabrication shop, we've been building ADA ramps and railings for nearly a decade, and we are yet to have a fabrication where we've built prefabricated a ramp railing prior to the concrete being there and have it actually fit. Most ADA ramp rails that we find once we're in build are either 4 feet too long or 5 foot too short. And now that we go out and we scan, we're able to actually say, hey, this is the way that it is, and give those kind of measurements one way to the other. Even though that was supposed to be laid out, sometimes when those elevation changes with mud and other geotechnical stuff, it doesn't actually work out for the ramp slope requirements. And usually the concrete guys setting the forms will just kind of float to the needs that it needs to happen. So any ADA rails and ramps have really helped us with the scanning get to where we need to go. We'll get to one last project that we'll speak of before we take any questions on this. Let's go to Thomas. Or you have your fossil code stairs. One more. As we pull this one up, we're able to work a lot more directly with the architects on projects, and we've done a lot with architects now to give them as-built of what they're going to be offering for their clients. So instead of them going in and making models and renderings and then them just going and putting in the markups, doing field verification or field verify this, field verify that, we've been able to actually go out and offer scanning as a service as a welding shop and actually give them the ability to have as-built ready and available. And we were surprised that as a welding shop, getting calls from architectural firms and engineering firms for this service, because it seemed like there wasn't a lot of surveyors in our particular area or our industry that had scanners that were offering this. So it's been pretty cool to do that. The last one that I'll talk about is a project that we were tasked to build the stairs ongoing with the framers, because the contractor was under the gun and needed stuff to happen. He wanted us to build the stairs as print, and stood tall and said, no, we don't build or fabricate anything off of print, especially a stairwell, because it never fits right. And we're always the bad guys when it doesn't fit. So this is a stairwell that when we went out and scanned, the framers and the footing and foundation tradesmen actually made this stairwell 10 inches too narrow. You can see the problem and the issue. If we would have built the staircase the way that it showed on the print, our stairs actually wouldn't have fit in the stairwell. And so through LiDAR scanning, we were able to do measuring over and over again and make sure that these stairs would fit. And not only did the foundation gentlemen mess up on their end, the framers actually sloped the decks on the stairwell here where they weren't supposed to. The stairwell, the decks were not supposed to slope with a pitch or a slope. However, when we went and did our scans showed otherwise. In this photo, you can see here where the stair treads are straight. They're level as the model is, but that whole balcony actually sloped down 3 inches in 8 feet. And if we would have built the stairs just regular, like a regular fab shop, there would have been a lot of rework in the field, but we're able to accommodate and see that very clearly on this. And we've been super happy with it, with the way that we do our workflow. Just to talk a little bit about the scanning to wrap up is when we're out on site, the scanners have a lot of settings and usability. For the majority of what we're doing, since we're doing stuff in close proximity, we're only running scanners on usually the lowest density and the fastest capture settings possible to get these kind of dimensions and accuracies that we're looking for. Because the way that these scanners are working now that are newer, they're processing data faster, they're capturing more points, and the data is actually smaller than it has been historically in the past. Historically in the past, point cloud data has been really hard to process, both on the beginning side and the ending, but I really feel that in the next 5 to 10 years, maybe even the next 2 to 5, that LiDAR scanning and 3D scanning is going to be just one of those really normal things on job sites, because the data is actually easier to be seen. Computers are stronger, our graphics cards are easier to manipulate and to grade than they ever have been. And so that's why we've really leaned into this kind of workflow into SketchUp and into point clouds. And then maybe some of you guys might be asking, well, what do you do with your rendering afterwards? And we would do just simply as most architects do in SketchUp when they render their projects. And we go to layout, and I'll let Mark speak to that for a couple minutes.
Yeah, layout's super rudimentary, but it gets the job done. So this belongs to that first project I showed you with the cable railing here. We did the whole thing, all the posts were laser cut, so you won't see a lot of dimension for fab, but you can take views of every single piece and you can change your access points in the model, and you can just create views of all your railing pieces and bring them in and do close-up views, do all the things that you could normally do. It's just it's a lot of hand drawing instead of automatic stuff like TechLove, SolidWorks, and things like that. A lot of it is like you've got to pick the point, hold the dimension, and make the print on your own entirely. You can like all this bottom is like set up to be my little template or whatever, but that had nothing to do with creating this. It's just a blank square to start with. I use the scenes in SketchUp and move on from there. But yeah,
you
super
guys
rudimentary, but it works.
Will you guys use the scan data and the layout view as well?
Yes, I can. So I think I use it at the end here to help the guys in the field know where each rail was. This wasn't a great example. I've had other ones where I can show exactly where on this giant square log this had to go on, otherwise it wasn't going to work. Or and it's hard to remember all the reasons I've used it, but most of the time it's just a visual for the guys out on site. Or sending this to a contractor, I'll do it for submittals all the time where I'm showing them like, hey, this is in my way. Here's your two different options I can do. You can either get rid of that thing, or I can put it basically to the side of it or in front of it, move it around. So it's super useful. It's a little grainy and hard to see like when you're making the layout, but as soon as it prints, it almost prints like perfect little dots in the picture as if you were viewing it in SketchUp in the first place.
Yeah, and it makes RFIs super clear when we do have RFIs in the field that needs to be answered, because then nobody has to go back through and look at what number, what detail, or try to figure out exactly what we're trying to ask in an RFI, because RFIs, as you guys know, clarification from one party to the next. And so when we could show that and say, hey, how should we answer this? And look, this is actually how it is. And before, our clients would ask us, well, we need to do in-field measurements. But now a lot of our clients, they know and realize what we're using. And they'll actually ask us to pull extra dimensions to give to other sub-trades more information now. Because they know that through our process of working with us on their particular projects, that we're going to be scanning throughout the project to make sure that when it's our turn to play the game, that we can win. And so it's really helped us make sure that even on RFI setting, that the friction is less. And so I think our time is just about up. If you have any questions, we'd love to answer any questions on whether it be the scanners or stations or field link that we have on the workflow that we've got.
Hey, Mark, real quick, maybe I might have missed it, but the thing that was really intriguing to me when I've looked at your workflow is how you're snapping to the point cloud in SketchUp to create the different design elements of what you're trying to fabricate there. Did you touch on that when we were talking about this?
I don't think I did. I didn't know how much time I had.
Yeah, we got about 4 minutes left on our presentation.
But SketchUp does have a really cool
feature.
Where it has this little magnet up here, and you can choose to either pick the point cloud first or your model first, and that helps with a lot of things. So if you're trying to pull a dimension here, as long as that magnet is on your cloud and you're hovering and you're like next to this piece, it's choosing the point cloud behind it. So if you want the point cloud, you hit that, then you can snap to your access and switch your magnet back to SketchUp, and then hit the part of your model and be like, okay, I've got that 23 inches, blah, 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 away from the actual wood, not my plate in this case. So that's something I use constantly. I've got it on a little hotkey. I'm just switching back and forth all day. And then also probably touching on the same, sorry, I've got so many models open right now. Probably touching on the same concept. sometimes when you're scanning big projects, you've got things on all sorts of different access points, and it becomes a pain to draw in any 3D reality. So my favorite thing to do is change my access back and forth. So like this ramp is not perfectly square with this square over here, which it was probably pretty close, but just as an example. And so when I first bring it in, I'm just going to make sure I'm going to choose a footing or a certain thing. So I probably use this hot tub to make sure that my pergolas were straight with each other. So I'm going to use this hot tub wall, and I'm going to make sure I'm picking the point cloud, and I can just hit here, and I can drag, and I just come down, make sure I'm on the same wall, but down lower, and I hit that, and then I can lock my blue axis. So that my level doesn't ever change, because the scanner is always level. And then I can come back and relate it to the first point that I drew, and I can finish off that triangle. Now, and that wall wasn't the best scanned wall, but you get the idea. As long as this triangle looks like it's on the same plane as the wall, then I can come up and change my access. And now I'm drawing square off of that wall. And that works everywhere. So now I can go back and I can do it over here and do it over there and just be square with how they built those stairs or that thing, and it's all in one model, and I don't have to separate everything into little chunks to get it done. And I also don't have to worry about my scan being perfectly aligned in field link. I like to get it close because it's easier to work with, but if things are off, they're off. So if you can do it in the program you're working on and you don't have to keep going back to the tablet, then it's always a win for me. And a little trick is I just draw something once I've made my access. I'll just draw a bar or the first part of my box or something and leave.
Mark, you cut out, buddy. So
sorry.
we're losing the last couple sentences.
Oh, sorry. Is my voice cut now?
Yeah, we lost the last couple sentences there. Sorry.
Okay. So with the access thing, a little trick I like to do is draw a box or something that relates to that access point. And so at any point when I'm moving around the model, trying to switch back and forth, I can always just come back to that box or straight piece and just snap my access back to what I'm going to start drawing on again. So those are major tools that I use constantly drawing.
I felt like that was the key, like especially like on the ADA ramps, to be able to snap to the point cloud to adjust the heights of the vertical components of your railing, so that they're fabricated at the correct slope to match your poured concrete. You know, to be able to snap to that point cloud is everything. And so
Schillman inspection tool on your bit. Yeah, and that's one thing that SketchUp does really, really well. When we trained other individuals on other processes, other softwares, they're not able to do that necessarily in those softwares. They don't have that option to pick this point. And so in some other softwares, they have they'll just kind of have to hover over that point or get it relatively close. But SketchUp does this really well where it will snap to it. And that's one reason why we think SketchUp is superior when you're doing something in this kind of area. Another thing that SketchUp does is it has what they call an inspection. And in the point cloud settings, where we can inspect and add in a different comparison distance to the model that we've drawn, we want to inspect and see how much overlap there is with the point cloud versus the model. And you'll see in this one that there's some very light points on there that you can see. Mark will increase the point sizes there just for use of and you can see those little tiny dots. There's some discrepancy with those dots with the base plate touching that, but it's all on his inspection map. It's all within 1 millimeter. of distance, or that's 4 millimeters. Sorry, excuse me. Now he turns it down to 3 millimeters. The less we go, the more accurate Mark is on this. But it allows us to double check our work right then and there, and to see where we're at. And if it's within 1 millimeter from a model to a point cloud, you're probably going to guarantee that the install is going to install it. 1 millimeter. I don't know what that is in the Imperial system, but it's so small that they're going to install this. It's not going to come back to the shop. We really like
that's the
Yeah.
beauty of the workflow right there, and that's cool.
Yeah.
I'm so glad you
And you
showed
can-
that inspection tool
and-
as well.
Show the layering, your color and layering.
Oh,
concrete
yeah,
layering.
yeah.
You got the different color map schedules in SketchUp to be able to do quick elevation checks. We do this quite a bit to see how the concrete is, different colors. If you're familiar with viewing point clouds or geotechnical data, the different colors on this kind of a view give you the highs and lows of concrete. So we're able to get some concrete guys into a little bit of trouble with our contractors when we bring our scanner out, and there's discrepancies between how flat is this concrete. Well, we'll find out really quickly in every little area. In fact, we were able to have a row of townhomes get all new garage floors because they were not flat.
Which I have a note to add to that. You can get a good visual in SketchUp, but if you really wanted to set an actual distance, like when the color is going to change or what the elevations are, Trimble Connect is 1,000 times better at this view, just because SketchUp have settings for this view. It just turns on, and it's just a good quick visual. And I don't even know what the tolerance is in this view unless I go and measure between there and there.
Yeah.
But
And FieldLink also does the same thing, and that right on the tab as well.
it's just harder to get a good clear photo like this.
Yeah, it's awesome.
Right.
Cool, guys. We got to jump on the next presentation, but I kind of lengthened you out there a little bit. That was exactly what we wanted to see there. Really appreciate your willingness to share that with some of those industry secrets that you guys have really thought through and figured out on your own, and very, very cool application of point clouds relative to design. That's the focus there.